a little bit.
Okay.
So I'm going to repeat a little bit. So in solving an absolute value inequality, the easiest thing to do is to go back to a very basic set of principles of just what if you have an absolute value inequality that looks this simple. Absolute value of x is less than a, or absolute value of x is greater than a. Just one number here, absolute value here. This would be an example. Absolute value of x is less than 3. And what I did is just on a number line, I just figured out where are the numbers whose absolute value is less than 3. Absolute value can be thought of as just the distance between the number and 0, how many units away it is. So like 2 has an absolute value of 2. It's 2 units away from 0. Negative 2 has an absolute value of 2 also. It's also 2 units from 0. So any number between negative 3 and 3 would have an absolute value that's less than 3. Not 3 itself, because the absolute value of 3 would be 3, and this is less than but not equal to. So the number line picture for this inequality looks like this. And that inequality can be described in an easier way by simply saying that x is between negative 3 and 3. And what you'll see in a little while is that we're going to use this sort of like a template anytime we have an absolute value inequality with a less than, which is going to apply here. So sooner or later, I'm going to get around to your question.
Gotcha.
But you'll see why this is worthwhile in a minute. So absolute value of x greater than 3, I'm going to make these a little bit closer together. So let's say that 0 is here, 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, negative 4, negative 5. The numbers whose absolute value are greater than 3 would be like 4, or 5, or negative 3, or negative 4, or negative 5. Well, actually not negative 3, because it's not equal to. Basically, anything that is bigger than 3 would work. So anything here, 4, 5, 6, 7, 8, or anything less than negative 3 would also work. Negative 4, negative 5, negative 6, all of those have an absolute value greater than 3. Does that make sense?
How come the negative sets? Just my question.
Okay, absolute value ignores whether you're on the left or the right side of 0. It's how many units away. So for example, if you wanted to know the absolute value of negative 4, what you do is you count how many units is it between negative 4 and 0. 1, 2, 3, 4.
That's higher than 3? Or
And
greater
that's higher than 3, right? Yeah, that would be greater than 3, so that would be part of my solution set.
Okay, and so it's at negative 3 because it's equal to, correct? Or no?
I have the round parentheses to indicate that that number itself is not included. Because this says greater than, negative 3 itself would not work. The absolute value of negative 3 is 3, and that's not greater than 3.
Yeah.
Okay. If I change that to greater than or equal to, then I'd put a square bracket.
Gotcha.
Okay.
Mm-hmm.
So does that make sense that these are the numbers that would make the absolute value greater than 3?
Yeah. I mean, obviously, I understand why it's going that way, and so this way, I'm going to the left. Not necessarily that I don't get it at all. It's just okay. Well, so really, your focus is supposed to be on 0, correct?
Distance from 0, right.
Distance from 0.
Absolute value is distance from 0. The absolute value of negative 4 is the distance from negative 4 to 0. How many spaces is it? You literally count 1, 2, 3, 4 spaces.
Okay.
And see, distance is always positive. So the negative numbers are the same distance away as the corresponding positive numbers. 5 and negative 5 are two very different numbers, but they're both the same distance from 0.
Mm-hmm.
And if all you care about is distance, not whether it's on the left or on the right, then you get the same absolute value.
Gotcha.
Okay.
Yeah.
Now, the reason we're doing all this is to show that when you have an absolute value that's a greater than a certain number, there will always turn out to be two different intervals that will work. And you can't really describe two intervals with one inequality. You have to describe them separately. So the piece on the left could be described as x less than -3, and the piece on the right could be described as x greater than +3. And the idea then is that for the purpose of solving inequalities, when I see an inequality like this, I'm going to rewrite it as two inequalities like that. Just like if I see an inequality like this, I'm going to write it as one inequality like that.
Gotcha.
So let me finally get around to answering your question. So here we have an absolute value that is more complicated, as you can see, but it has this same format of being the absolute value of something or other equal to a number. So what we will do is we will use this pattern as sort of a translation. We've got the 3, and this is a less than or equal to. What we will do is we'll say, let's rewrite that to where instead of saying the absolute value is less than or equal to 3, we'll say that whatever that is in absolute values is between -3 and +3. Kind of using this as a pattern. If it was just an x in the absolute value, you put the x between the positive and the negative of whatever this number is. If it's something more complicated, you just put that instead.
Gotcha.
Look good?
Mm-hmm.
All right. Now, once you have that, you've got a triple inequality. And these were, I think, more covered on the Math 0314 side, but these are easy to solve because that principle of balance, where we ordinarily say whatever you do on the left, you also do on the right, that applies even if there's 3 parts. Whatever you do on the left, you also do in the middle and on the right. You do it in all 3 places. And if your goal is to get the x by itself, you think about what could I do to get that x by itself. And if it helps, what you might do is just cover up one part of this so it looks more familiar. And even think about, well, what if that was an equal sign? What would I do to get the x by itself if say this is all we had and that was an equal sign? What would I do?
You would minus 10.
Yeah.
Subtract 10 from both sides.
And with a 3-part inequality, you just subtract 10 from all sides, from the left, from the middle, and from the right. So that's the idea of balance continuing on. What you would have done if that was an equation, you just do it in all 3 parts. And that gives you a -13 here, and a -4x here, and a -7 here. And again, your goal is to get the x by itself. So what else would you do? And again, if it helps, just pretend there's only one piece, and that's an equal sign. How would I get the x by itself if that's all there was to it?
I'm assuming you would divide.
Mm-hmm. And the only deal is you do that not just in 2 parts, but in 3 parts, all the way across. Now, these numbers didn't turn out all that great, but that's okay. -13 over -4, a negative over a negative is a positive, so you can say 13/4. And a negative over a negative is again a positive, so you can say 7/4. And here, though, the -4s divide out and gives you an x. But there's one special thing you have to pay attention to when you're solving an inequality. If you ever multiply or divide by a negative number, the inequality has to turn around. Remember that from somewhere? If you multiply or divide by a negative number, the inequality
Mhm.
has to reverse. So instead of
Gotcha.
less than or equal to, they become greater than or equal to. And
That's anytime you divide, correct?
yeah, by a negative number. If you divide by a positive number, you leave it be. But if you divide by a negative number, you switch the inequality around.
Okay, gotcha.
And that kind of makes sense because 7/4 is actually the smaller of these two numbers. And what this is basically saying is that your x is between 7/4 and 13/4. So in interval notation, you just say 7/4, 13/4. Oh, I don't know why I made that 14. 7/4 and 13/4 with brackets.
Does it matter which one goes first?
Yes, the smaller number always has to come first.
Okay, gotcha. Alrighty. Okay, gotcha. So just to make sure I understand, could you possibly write one? Or
Beg your pardon? Say it again. I missed you. I missed what you said. Sorry.
no, you're fine. I was saying just so I could practice this, could you by any chance write a problem and see if something, I guess, somewhat similar?
You know what I'd like to do? I'd like to do one that has this greater than that I'd like to work with you, and then I'm going to let you do one if that
Okay.
sounds good.
Yeah,
So
for sure.
so the situation is a little bit different if your inequality involves a greater than. So what if we had absolute value 3 plus 2x greater than 7, greater than or equal to 7? Just put that in there. Okay, so again, you're going to rewrite this absolute value inequality so it doesn't have absolute values, and it involves translating this kind of using a template. Sorry about that. My cats are having an argument. There's some growling there. They're not happy with each other.
Uh,
So when you say that the absolute value of x is greater than 3, that happens when either x is less than -3 or greater than +3. So if the inequality is more advanced, just say what you'll do is you'll say whatever that is in absolute values is either less than or equal to the negative number or greater than or equal to the positive number. Absolute value greater than 7 means that the stuff inside the absolute value bar is either less than -7 or greater than +7. And that's using this as sort of your template. So that's when you have a greater than, you're always going to get two separate inequalities, but that's okay. You just solve them separately and we'll see what happens. So if I had this inequality, what would I do here to get the x by itself?
you would subtract 3 from both sides.
So that would give you 2x, and -7 minus 3 would be -10.
And then you divide 2.
And then you divide by 2. And because I'm dividing by a positive, I'm not going to turn the inequality around. I'm going to leave it just the way it is. If you divide by a positive, you leave it alone. If you divide by a negative, you turn it around.
Gotcha.
Okay? Now, separate and apart, we've got this inequality. How do I solve this one?
You would do the same thing, -3.
Yeah, exactly. Subtract 3. So 7 minus 3 is 4. And then divide by 2. And you get x less than or equal to -5, x greater than or equal to 2. They probably won't ask you to put this on a number line, but I'm going to do it just this one time. X less than or equal to -5 goes this way, and x greater than or equal to 2 goes this way. So see, there's two separate intervals. And the way you would have to describe those in interval notation you'd have to have two separate interval notations, basically. From negative infinity to -5 is the one on the left. From 2 to infinity is the one on the right. And then you also saw this in the previous section on inequalities. If you've got two separate intervals that work, you put that union symbol to mean this one together with that one. So absolute value greater than, you're always going to get two pieces. Absolute value less than, you're only going to get one piece.
Gotcha. Okay. All right.
Do you want to try one?
Yeah, let's see how it goes.
Okay. Okay.
In the meanwhile, I'll be right back, sir. Just give me 1 second.
Okay. Sure. Yeah.
Sorry about that.
No problem.
Okay, so that is the problem.
Yeah. You want to give it a shot? And,
Here.
I'm going to write part of what I had on the previous page. These are kind of your templates for the general form of an absolute value inequality with either a less than or a greater than. How you translate the absolute value inequality into a more recognizable one. So that might be useful to you as you try to work on it.
Gotcha. So, I mean, obviously, this is something that I want to work on myself, but the first step would be putting this in between less than or greater than. Here, let me write it down.
Okay. Yeah.
You start off this way, right?
All right. Let's see. Those should both be less than or equal to's.
The one I got wrong, right, where the positive 10 is?
See how these point the same way?
Yeah. Yeah,
You
okay.
point one way and one the other. They both need to point. They both need to be less thans.
So then that's when you start solving, correct?
Right, exactly.
To get the x by itself, you add 6 on both sides.
Yep.
Could you just add on one side or all sides?
All sides. Yeah. That balance, once you have, if you have three parts, that principle of balance expands, that whatever you do on the left and the right, you do in the middle too.
-4 less than or equal to 16. So I'm assuming at this point.
Can I show me your paper again? Let me just look at it and let's see. So you've got, and you're going to add 6, so that becomes -4. Okay, you're good so far. Yeah, so far so good.
Not all of them. Right positive, you would need to flip. Hello?
Yeah, I'm here. Are you?
Were you there all this time?
Oh yeah. I mean,
Oh
I was
my,
just waiting on you.
oh my goodness,
So,
I'm
you
so
okay?
sorry. I
Yeah.
thought I thought you went somewhere. That's
Oh
why.
no, I'm here.
Oh my goodness, wow, wow. Yeah. So,
Yeah, let me see
uh,
what you got.
yeah. Well, so whenever you divide the -4 and the +4, the sign is going to flip, correct? Since it's negative.
It all depends on what you're dividing by. What did you divided by a 4, right?
Mhm. Yes,
And
sir.
that's a positive number. So since
Yeah.
you're dividing by a positive, you leave the
Oh,
inequality.
okay. Okay, so pretty sure you would just have to put it in a kind of solution set sort of deal, but that's
Yeah, let's take a look. Yeah, yeah. So I want the answer in interval notation. Everything is perfect so far. How would you describe that as an interval?
um like how would I write it in?
Yeah, like in interval notation, something like,
Okay.
what would it look like? Yep, good. Yeah, you got it right.
And so the thing I still find confusing a little bit, I guess I'd say, is the just where the signs are supposed to be pointing. That's where I find a bit confusing at.
Yeah,
I
yeah,
know you explained it pretty well. It's just
yeah. It's probably going to be a matter now of just sort of remembering the way it is. Absolute value less than always becomes a three-part inequality with the x in the middle, and all the inequalities point less than. So they will stay the same. Less than, less than, less than. Absolute value greater than, it'll translate into x less than the negative or x greater than the positive. And you almost kind of have to memorize this as like your,
oh, okay.
yeah,
I sort of
yeah. I mean, you want to
okay.
understand it, and then once you understand it, you want to just kind of remember, this is the way it always is.
And that's what you were explaining is that with the one on the left, that's just going to be a one part, and the one on the right it's going to be a two part, and
Right,
then yeah.
right.
So in this case, the reason why we only have one part is because it's um the less than, correct?
Yes, yeah. Absolute value less than will always have one part. It'll become a three-part inequality with the quantity and absolute values between two things.
Okay, that makes sense.
Absolute value greater than will give you two parts, less than the negative or greater than the positive. And it is really easy to think, oh, I get the greater than or the less than in the wrong place. So you have to be really careful about that. X less than the negative or X greater than the positive.
Okay, awesome. So could you give me a scenario where where it would be split apart?
Like this? Okay.
Yeah.
Yeah. In fact, I'm going to put a negative in here just so it's interesting. Um, so try that one. That'll be more like that form.
So you set it that way, right?
Can you move it? Yeah, just a little bit. Now help move it up a little bit. Okay. No, you're going to have to write this as two separate inequalities. Um, if you write it the way you're writing it, with the absolute values going in different directions, it's going to really get weird. So write it as two separate things. This or this.
Something like that, right?
Uh, the one on the left should be 5 minus 2x less than negative 9. The variable will be on the left side of this always.
Oh, the way I did it over here is correct then, right?
Yeah, what you had on the right was right. Yeah. Yeah, the one on the right's good. The one on the left, the variable expression should be on the left. So you just turn that around.
So it'd be 5 minus 2x is less than -9.
Yes, that's exactly right. And then that's two inequalities, so you solve them separately.
Yeah. So you would both you would so then after right here you would divide both sides by 2, correct?
Let me just see what you got. So you are going to first of all subtract the 5. The one on the right is perfect. The one on the left, you lost the negative sign in front of the 2.
Oh, okay. So in this case, since you're yeah, so since you're dividing by -2, the signs can flip, right?
Right, exactly right.
So would end up being this correct?
So you have, look carefully at the numbers on the right-hand side of both of those. One more time. The -14 divided by -2, and also the 4 divided by -2.
Okay. Oh, okay. I see what I'm doing wrong. Hold on. I got that'd be +7 and -2 then.
Yeah, so x greater than 7 and x less than -2.
Hmm.
Okay, great. Good. Now, since that's describing 2 intervals, you're going to have 2 interval notations, one for each with a union in between them. So what would those look like?
Wow.
I think that's what you've got right now. So, oh, okay. Let me talk about this a little bit. So the interval notation for x greater than 7, like this, an interval notation will always have just 2 numbers between brackets or parentheses, a leftmost number and a rightmost number. When you have all the values of x greater than 7, What that would mean is that the smallest of your numbers is 7, and they keep on getting bigger and bigger and bigger until you go off towards infinity. So that first interval, you'd write it as 7 to infinity.
Okay.
And the second one, you're going, if you think about the number line, that's from -2 to the left. So the -2 is actually the rightmost number, and it goes forever in the other way. How would you write that?
Infinity or negative infinity?
Negative infinity. And then you put the union symbol in between them.
So how would that look uh, on a line?
Online, there should be in the online system a
Oh
template that,
no, I meant like on a line.
oh, on the line. Okay, yeah. Okay. So here's what that looks like actually. There's the 7. Here's the -2. So 7 to infinity would begin at the 7, not including the 7, and going to the right. But negative infinity to -2 would be starting at the -2 and going to the left. Like that. So this piece is actually the left piece, and this piece is actually the right piece.
I see. And once again, that does that matter where which one is which?
This doesn't really matter. A union is a set concept, and in a set, the order of the elements doesn't really matter. So it should accept it whether you put this one first or this one first.
Okay, well, that makes sense for sure. Great. Well, okay, that solves that problem.
Okay. I'm going to close I have my email going on in the background and it keeps dinging. So
Yeah, go ahead.
let me turn that off real quick.
Yes, sir. So this one is somewhat similar, except it just has an equal sign though. Um,
All right,
all
I got you
right.
back. Okay.
So let me show you.
Oh, okay, just with an equal sign. All right. That's good. That'll kind of hit everything you can do with absolute values. Actually, can you show it to me one more time? I'm sorry, I
Yeah,
didn't.
no, you're fine. Of course.
6 minus 5x equals 3. Okay, so actually this is going to be easier. We've looked at absolute value less than, we've looked at absolute value greater than, now we're going to look at absolute value equal. And this is actually going to be really simple because all you have to do here is say, this will be true if that's equal to 3 or if it's equal to -3. Because if it's equal to -3, the absolute value of -3 is still 3. There's two numbers whose absolute value would be actually equal to 3, either 3 or -3. So you split this up into 2, kind of like you did with the inequalities, but it's just an equal sign this time. 6x equal 3, 6 minus 5x equal 3, 6 minus 5x equal -3.
Okay. Okay.
And then that gives you two equations. Each
You
one is
just
going to
solve.
be a single number, and you just solve them individually.
Gotcha. So
So,
minus x on both sides.
mhm.
Okay. Sure. I'm not scoring these because I'm not saying these are the answer, but I'm
Yeah. So far, so good. Yes, yes, you're good. You're so far, so good.
so then with that you would divide -5 from both sides.
Yep, yep.
So I'm not sure if I'm right. X equals -3/5, and then x equals -9/5.
Think about your positive and negative sign. If you've got a -3 and you're dividing by a -5, a negative divided by a negative, what would that
Give you
give you?
positive.
Positive, yeah.
It's the same rule as multiplying negatives. When you divide them, it'll give you positive.
Yes, yes.
So I'm guessing the other side it's going to be 9/5.
That's it. And for equations, they like you to write the answers as a solution set like that.
Gotcha. So real quick, well, I mean, obviously, I know you probably don't want to say much about the test, obviously, but so it's just a bit hard to with this. It's not too difficult to remember, and the other things that I was learning. But when it comes to like the word problems,
Mm-hmm.
there's so much steps behind them.
Mm-hmm.
For me personally, would you? I mean, and that doesn't take away from the fact that I'm going to learn from it. I'm going to try to understand and learn it. But would you say I should focus more on the word problems, more on questions like this? Um, I mean, I
Well,
will.
the test definitely has a word problem.
Hmm,
It only has one, but it counts. I think it counts for 8 or 10 points, so it's pretty. It's important. So you don't want to blow it off. Most of the other questions are going to be just abstract questions like these, solving for either an equation or an inequality for x, or maybe earlier on working with the complex numbers, adding, subtracting, multiplying, and dividing complex numbers. So most of them are, there is one word problem, the rest are more abstract. What I will promise you is that the questions on the test are truly very similar to the ones on the practice test. So if on the practice test I gave you a word problem about an object being thrown into the air and the initial velocity and all that, I'm not going to give you a question on the test that talks about, say, temperature and um, volume and things like that. I'm going to keep it same type, so you don't have to reinterpret something radically different.
gotcha. Okay. Okay.
So, and like,
So,
there's another word problem about the area of something, a wall or something.
yeah,
Maybe
that was the barn.
maybe it might not be a wall, but maybe it's a door, but it'll still be an area problem. I'm not going to ask you something about, uh, I don't know, converting Fahrenheit to centigrade, something radically different. I don't want to throw you off or anything, so it'll be similar in nature.
Gotcha. Yeah, I mean, I know I keep going back to that one question, but the velocity one was just um, a lot of information to that. But yeah, definitely would have to go back and look at that. So here's another question.
Okay.
Uh, let's see. So it's solve the rational inequality,
Mm. Mm-hmm.
and it's 42 over 6 plus x plus 6 less
X,
than or equal. Yeah,
was it
less
6
than
plus
or
X?
yeah, that's x plus 6. I'm sorry.
Less than or equal to
7.
7. Okay, great. All right. Now, the first thing I want to do with this one is urge you not to do the thing that looks like it's easiest. And so far, looking at everyone's test papers, no one has done this. So I'm really, really glad about it. I've kind of tried to make a big deal out of it. At first glance, you might say, oh, I don't like those fractions. So I'll just multiply both sides by x plus 6 and make them go away. And then it becomes like super easy and it's like, oh, this is no big deal. But you don't want to do that. And the reason is, it goes back to the fact that when you multiply or divide by a positive, you leave the inequality alone. If you multiply or divide by a negative, you turn it around. And here's the deal. X is a variable. You don't know what it is. So when you multiply both sides by x plus 6, since you don't know what x is, you don't know if you're multiplying by a positive number or a negative number. And since you don't know whether you should leave the inequality the way it is or whether you should turn it around. And since all of that is unknown, you can't do this even though it looks so easy. You don't know whether to leave that less than or change it to greater than. And the reason I say that is what you do have to do is seems like a whole lot more work. And it'd be like, oh, can I just get away with that? But it won't work. You got to do it this way. So
Yeah.
what you have to do, you have to get a 0 on one side. And to do that, you just subtract the 7 like that. Then you have to get one fraction on the other side. So I've got one thing's a fraction, the other one's not. But you can always make something into a fraction by putting it over 1. 7 is the same as 7 over 1. And in order to combine those two fractions, I'd have to find a common denominator. And that's not too bad, because what that common denominator could be would just be the x plus 6, and I can multiply the top and the bottom by x plus 6, and now there's a common denominator. So this is working with fractions, which you've played with a little bit on the 0314 side. I had some of these, getting used to this sort of thing. Does that make sense?
So the x plus 6 is just a denominator from the
It's the, yes, yeah. I'm trying to get the same denominator in both fractions, and I can always multiply the top and the bottom of a fraction by the same thing. That's legal. It's like multiplying by 2 over 2 or 3 over 3 or 4 over 4. Those are always just multiplying by 1. If I multiply by x plus 6, the denominator is the same, so you can copy the denominator and combine the two numerators like this. The numerators I'm just combining. The denominator I'm just copying.
okay. And I'm assuming you would factor out the 7.
Yeah. Then you would, the magic word we want to use is we're going to distribute the 7.
Distribute. Yeah, sorry. Yeah.
So minus 7 times x, and minus 7 times 6 happens to be minus 42. That's kind of convenient. And then the 42s, you can see, will add to 0, and you get minus 7x over x plus 6 less or equal to 0.
That'd be your final answer?
No, not yet. Not yet.
Oh, okay.
And In our final answer, like the inequalities we were doing with the absolute values, you need to have the x by itself. The x is not by itself yet. So, in fact, what's going to be extra challenging here is that there are two x's. There's one in the numerator and one in the denominator. And I can't just divide them out because the 6 does not have an x as part of its term. So when you have either a rational inequality or a quadratic inequality, you want to get a 0 on one side first. And once you do that, then you do something kind of fancy. And I'll just tell you, every instructor has their own way to explain this. I'm going to show it the way I do it. But if you look at the videos for section 1.7, I think this is, I have some videos that I made showing it my way, and then I put some other people's videos in it to show a different way. So I'm just going to show you my way. What you do when you have x's in more than one factor is you have to look at each factor individually. And what you do, and this is going to seem a little weird for a while, you're going to set each factor greater than 0. And by each factor, I mean whatever's in the numerator and whatever's in the denominator. And you might say, well, wait. The question says less than or equal to. Why are you saying greater than? Well, I'm going to explain that later. So I'm just going to have you trust me for a minute.
Mm.
Okay. Then you solve these for x, because now I've separated them out so they're solvable. This one, to get the x by itself, I would divide by -7. Remembering that if I'm dividing both sides by a negative, the inequality has to turn around. So that'll be x less than 0. This one's not so bad. I'm going to subtract 6 from both sides. And if you're adding or subtracting, you never turn the inequality around. You never change it. Only when you're multiplying or dividing by a negative. So these are the solutions of the two factors separately, the numerator, the denominator separately.
Mm-hmm.
But then you got to figure out how they go together. And that actually can be kind of complicated. So I set up what I call a sign chart. And here's how this works. So what I do first is I make a list of my two inequalities that I just looked at, or the two quantities I just looked at. I'm going to look at the -7x from this inequality and the x plus 6 from this inequality, the two factors. I'm going to draw a number line. And on that number line, I want to locate the numbers that I got when I solved the inequalities separately. So notice I got a 0 and a -6. I want to just put those two numbers on the number line, and this does not have to be to scale. I don't actually have to count 1, 2, 3, 4, 5. The important thing is that -6 is on the left and 0 is on the right. Now, what we want to do is we want to look at what's going to happen when we put these together. So the the expression that I'm really interested in is this one. So below the number line, I put that expression. Now, here's what I do next. So next to each of these different factors, I look at the inequality that I have, and I remember that I was looking for that quantity greater than 0. So what this is saying here, what this work is saying here, is that for any choice of x that's less than 0, -7x is greater than 0. Greater than 0 is positive. So what I'm going to do, and this is how this is called a sign chart, is for every value of x that's less than 0, I'm going to just put a whole bunch of little plus signs. And what these plus signs indicate is that if x is less than 0, then the negative 7x is greater than 0 or positive. Now, the reason that you only look at each factor greater than 0 is because if you look at that, you get less than 0 for free. If all of these numbers to the left of 0 make that factor positive, then all the factors on the other side of 0 must make that factor negative. And right at 0, if you plugged in a 0 into negative 7x, you would get 0. So this factor here is positive if you're to the left of 0, negative if you're to the right of 0, and 0 if you're right at 0. That's kind of a fancy way to write the number line solution for this inequality. Okay? And this will see, if you haven't seen this before, it'll feel like, whoa, where is all this going? So you got to kind of just trust me for a little bit. And then it'll become, it's like, okay, I get it. I don't see why he's doing it. That's all right. Now, looking at the second factor, which is this one, the work we did here said that if x is greater than negative 6, that means to the right of negative 6, then x plus 6 is positive. So for any value of x that's greater than negative 6, the factor x plus 6 will be positive. So x greater than negative 6 to the right of negative 6, x plus 6 is positive. And then what you get for free is that if for all these values of x the factor is positive, then for all the values of x on the other side, the factor is negative, and right at that point, it's 0. So that's looking at each factor individually. Do you kind of see what's going on there?
Not really, but I mean, it's okay. I could rewatch the video.
Hang on to it. We can do another one too. And I'll go back through it once we kind of get there. I think in a minute it might become clearer what we're interested in. So the actual thing that we care about is this entire fraction, negative 7x over x plus 6. And we really want it to be less than or equal to 0. Less than or equal to 0 means negative. So we're looking for the values of x that make this fraction negative. But here's what you can do. In this part of the number line, for any value of x in this part of the number line, the numerator is positive and the denominator is negative. If you take a positive number divided by a negative number, the result is negative. So for all these values of x, from negative infinity to 0 basically, the quotient, the fraction of these two, will make a negative result. Positive over negative is negative. Actually, let me stay color coordinated. I was using black for negative. All right. Now, I'm going to skip over negative 6 for a minute and go between negative 6 and 0. For all the values of x between negative 6 and 0, this factor is positive. This factor is positive. If you take a positive number divided by a positive number, what do you get?
Positive.
Positive. So I'm going to put a bunch of little plus signs. Positive over negative is negative. Positive over positive is positive. And over here, negative numbers divided by positive numbers would give me what?
Negative.
Negative. Now let's look right at these numbers at negative 6. So at negative 6, your fraction is going to give you a positive number divided by a 0. Now what happens if you divide actually anything by 0?
0.
Almost.
0. Oh.
If it's 0 divided by a number, that's 0. But division by 0 is undefined. So any number divided by 0 is going to be undefined. Can't divide by 0. On the other hand, over here at 0, you've got 0 divided by a positive number. Now that's okay, and that is 0. So something over 0 is undefined. 0 over something is 0. All right. Now, we're actually, this chart, believe it or not, tells me the answer, because what you're interested in is you wanted that quotient, that fraction, to be less than or equal to 0. That means numbers less than 0 are negative. You want to pick out any value of x that would make your overall fraction either negative or 0. And that just means looking at this picture and saying, oh, it's negative over here, it's negative over here, and it's 0 right there. So I want to take all of this, and I want to include that endpoint. So here's how you'd write your answer. For all of these values of x, you get a negative number and you want it to be negative. So you say negative infinity to negative 6. You don't want to include the negative 6 because the fraction's undefined there. So you don't want to do that. And then in between, it's positive. But over here, from 0 on, for all of these values of x, the quotient is either positive or 0. So you've got a piece on the left, a piece on the right, and to say that you want both of them, you put a union in between. So that's pretty involved. Those questions are long.
A lot more than I actually thought you'd have to do. I thought it was going to be something a lot more
yeah,
simple, but this turned out to be
yeah. So,
wow.
but besides the one we're doing right here, I have a couple videos in the media assignment for section 1.7 where I show the same thing. And we can do another one here as well, but watch those videos also.
Mm-hmm.
And if you want to, there's some videos by another professor, and he does this a little bit different way. If you want to say, hey, I just think I'll stick with what Dr. Burgos doing, don't look at his. If you want a choice, look at his and then decide which one you like best.
Yeah.
And looking at the tests that have come in so far, some people have done it my way, some people have done it his way, and it doesn't offend me either way. Whatever makes sense for you.
Yeah. I don't know. How have people been doing on the test?
Not bad, not bad. I haven't looked at them all yet, but of the ones I've actually gone through, because I'm going through people's scratch work, I've done maybe 7 or 8 of them, and one person didn't pass, but all the others did.
Okay.
So not bad. Not bad. I mean, I feel bad for the one who didn't pass, but I think I can get her back on track. So do you want to do another inequality with a fraction in it just to kind of see how this goes again?
Oh man. Yeah. Give me 1 second.
Or do you want to go on to a different question and come back to this if we have time, whatever you like?
Yeah, let's go to another one, and then yeah, well, I guess we could go back to that one.
Okay, yeah, give me the one you want to do, and we can come back to this if you like.
Gotcha. Crap. Sorry. Okay, so it'd be negative x squared minus 5x minus 6 less than or equal to -2.
Oh, okay, great. Actually, you're going to do this one almost the same way. So I'm going to be able to illustrate a lot of the same things. This wild stuff with the sign chart, you have to do this if your inequality involves either a fraction, like it did here, or if it involves a quadratic expression, like it does here. Those are
Professor, I'm sorry. Do you mind if I use the restroom real quick? And
Sure, yeah.
all right, I'm sorry. I'll be right back. Oh,
Okay, you're back.
oh, sorry.
Okay, no problem, no problem. Actually, when we're done looking at your questions, I want to talk to you about some of the logistics of actually taking the test itself. So I want to save a little bit of time to do that. But let's take a look at this. So that idea of a sign chart, you're going to have to use that on any inequality that either has fractions or is a quadratic inequality with an exponent of a 2 anywhere, or in fact, actually even, you won't see any of these, at least you will later in the course, but if there had been a polynomial with an x to the 3 or the 4 or the 5, you'd have to use a sign chart there too. We just don't get that crazy. So similar to the last one, what you want to do is you want to get a 0 on one side first. But something that might help in this case that might make this one a little bit easier, notice that your leading coefficient here is negative. And working with quadratic expressions where you've got a negative is always kind of a little bit of a mess. But it turns out that not only is this one negative, so is this one, and this one. So what I could do really simply is divide both sides by -1. And that would have the effect, just off the bat, of making that a positive x squared, a positive 5x, and a positive 6, which just automatically looks cleaner.
You'll flip the sign.
Yeah, and you'd flip the sign because you divided by a negative, so you're going to make that from a less than to a greater than, and -2 over -1 is 2. And so just right off the bat, divide by -1 and everything's better. Now, like the one we did with the fraction, you start off by getting a 0 on one side. And that just means subtract the 2. And on the one with the fractions, what I did is I created one fraction. Here, very similar to that, but kind of in its own way, you want to factor the other side. So you get a 0 on one side, and then you factor the other side. So you look at your x squared plus 5x plus 4, and you ask yourself, can I factor that as something times something? Do you see a way to do it?
I do not.
Two numbers whose product is 4 and whose sum is 5.
So it'd be this is fine. I'm sorry, I'm like extremely tired.
It's all right. So give me any two numbers that multiply to give you 4.
2.
Two
2 times 2.
Is there another way to get a product of 4? Any two other numbers?
4 times 1.
4 times 1. There you go.
All right, well.
And see, that would give you the sum of 5 in the middle. That's the perfect one.
Gotcha. So real quick on the very top, why was -1 multiplied into all of them?
The reason I did that is, in general, a quadratic expression is just uncomfortable and hard to work with if your leading coefficient is negative. That negative x squared is what gave me the idea to do that. Dividing by -1 doesn't change it in any way, but it just means you've got all positive numbers.
Okay.
Nice trick. Maybe they'll never show up again, but if this is a positive x, you see how much easier it is to factor that. It's just easier. So now this is where it's going to begin to look like that last question. What you're going to do next is you're going to set each factor greater than 0. So that's actually what we did on the other one. Let me see if I can find it. Yeah. So right here, we set each factor greater than 0. Here also, we're going to set each factor greater than 0. So x plus 4 greater than 0, x plus 1 greater than 0. And it's always greater than 0 no matter what that sign is. Just always set it greater than 0, because what you're really going to do is you're going to get where each factor is positive, and then you automatically for free get where it's negative. So how would I solve x plus 4 greater than 0?
You would subtract 4.
Yeah, x greater than negative 4.
Yeah, I feel like this one's a lot more simple than the other one.
It is. It is.
Yeah, see, minus 1.
You're going to get simpler ideas, but you're going to get the same idea, but it is a little bit simpler. You set up a sign chart. So this is going to be like the last example. It's also going to feel more comfortable because you've done it once. In your sign chart, you make a row for each factor you see. So there's a row for x plus 4 and a row for x plus 1. And you draw a number line. And on that number line, you put the two numbers that you got as you were solving these individual inequalities. And mainly, you just need to get them in the right order. So negative 4 is actually to the left of negative 1. I'm just going to put the negative 4 and the negative 1, and I'm not too worried about that being to scale. Just get them in order. And the idea of what we're going to be doing is we're going to try to figure out, where is this factor positive and negative? Where is this factor positive and negative? Because if I can look at those factors separately, then down below, I can look at the product of the two factors, which is what I really care about, and decide whether that's positive or negative. Okay, so let's go to each one. X plus 4. X plus 4 is greater than 0. Greater than 0 means positive whenever x is greater than negative 4. So for any value of x greater than negative 4, x plus 4 would be positive. And you just put a bunch of plus signs. X plus 4 is greater than 0. That's positive whenever x is greater than negative 4. If x plus 4 is positive to the right of negative 4, then it's automatically negative to the left of negative 4 and 0 right at negative 4. So for all these values of x, this factor is positive. For all these values, it's negative, and it's 0 right there. See where that's coming from?
Not really, but yeah, I mean, it's just like practice, I guess.
So what I'm really doing is I ultimately have to look at the product of two things in an inequality, and basically that's too hard. I look at just the two factors separately, and I'm just focused on myself on, when is x plus 4 greater than 0? And this is basically just a number line representation of that. Just instead of coloring it in, I put the plus signs so I remember that it's positive over here. X greater than negative 4, bunch of plus signs.
Okay.
And then what you get for free is that if the given factor is positive on one side, it's negative on the other side.
Okay.
So let me see if that makes sense for the next one. So in this one, I'm looking at x plus 1, and it's saying that for all the values of x greater than negative 1, x plus 1 is positive. So the solution of x plus 1 greater than 0 is all over here to the right of negative 1. For all these values of x, this factor is positive, which means that for all the other values of x,
Negative.
it's negative. And right at that crossover point, it's 0.
Okay, that's sort of making sense.
Okay, so I'm looking at each of my factors separately because it's easier to look at them separately. Then I try to put them together. And the sign chart makes that doable because all you're thinking about is, if you're in this interval of numbers to the left of negative 4, this factor by itself is negative. This factor by itself is negative. So if you take something negative and you multiply it by something negative, what do you get?
Positive.
Something positive. So for all of these values of x here, you're going to get a positive result. Now, when you're at -4, you're multiplying a 0 by a negative. What happens if you multiply 0 by a negative number? What do you get?
0.
0. So I put a 0 right here. Between -4 and 1, this factor is positive and this one's negative. So what happens if you multiply a positive by a negative?
Give you negative.
Negative. And right here, this is positive and this is 0. So what happens if you multiply a positive by 0?
0.
And then beyond that, what happens if you multiply a positive by a positive?
Positive.
Positive. All right. Now what you do is you look back at the inequality where it was all together, where you had both factors involved, and you interpret what this means. So what you wanted is for the product of the two factors to either be greater than 0, which is positive, or equal to 0, which is 0. And you use your sign chart to pick out where are the intervals that made the product either positive or 0. Anywhere that gave me either a plus sign or a 0, I want to include. So all of these are positive. That's a good thing. How would I describe the interval that goes from -4 forever to the left?
X
I want
squared.
to write interval notation. So I want to do something like
Oh, yeah, negative infinity, comma, -4.
Yep, negative infinity, -4. Do I want to put a parentheses at the -4 or a bracket?
Parentheses.
That's all going to boil down to do I want to include the -4? Does the -4 do what I want? Does that give me either a positive number or 0?
No.
Actually, it'll give you a 0.
Oh, okay.
Okay,
Oh,
so
sorry.
at -4, you're going to get a 0, and that's a good thing. You do want it to be either positive or 0, so that's good. So you want to take all these. You don't want to take these because that gives you a negative. You do want to take these, so there's going to be a separate piece. We'll put a little union. And then how would I describe what goes on over here?
So it'd be parentheses.
Parentheses. Do you want to include the -1 or not?
No. So bracket.
Bracket.
6, comma, infinity.
It actually just straight from the number line. What's that number right there?
-1.
Yeah, just straight from the number line. -1, 2, and
Sorry,
4.
I was counting the positive things you wrote down here. That's why I said
Oh
6.
yeah, it doesn't matter. I'm just filling the space with positive signs.
Okay, so that really has no significance. It's just kind of to let you know that this side's positive, right?
This side's positive and the other side's negative. That's
Okay,
all.
gotcha.
So I just how many positives I put there doesn't mean anything. It's just all
Okay,
this is positive and all that's negative.
gotcha. So that'd be your answer then?
That's your answer. You're done.
Oh. So I know you've already. So I don't know by any chance if you'd like to write one down. Let's see if I can do it.
Yeah. So what I'm going to do is I'm going to write one down here on the right so that this whole thing stays visible and you can look back at it if you need to. I don't think I want to do this bit with the funny negative up front. That's maybe a little bit crazier than we need, but let's say, and let's keep it not too bad. Let's say x squared. Actually, I'm going to write something over here. Okay, I got it. X squared plus 2x less than or equal to 15. Oops, that's off the top. That's not good. Let me bring it down. X squared plus 2x less than or equal to 15. Okay, now you can see it. So try that doing the same steps. I've got them all written here. You want a 0 on one side. You want to factor the other side. Set each factor greater than 0. Create a sign chart. And then come to a conclusion when you're done. And I'm quiet, but I'm still here. So whenever you want to ask me something, just go ahead and ask.
Gotcha. Thank you. There's something that you wanted to mention about taking the test. Is that something you want to mention at the end?
Yeah, let's do that at the end. I don't want to break your concentration here. Just
Okay.
work on this, and when we're done, we'll talk about that. I'm muting myself for just a second there. What?
Are you still helping?
I finished, but I just want to make sure that I'm doing it correctly so that I'm not doing the rest of it
Okay.
incorrectly.
Okay.
My handwriting is a little iffy, so
Let me just take a look. So you subtract the 15, you get x minus 3, x plus 5, x minus 3, x greater than. So far, so good. Yeah, yeah. You are down to making the sign chart. So, and everything looks fine so far. I'm basically just catching up with you here.
gotcha.
Are you still unmuted?
Yeah. Mm-hmm.
Okay, I don't really have had too much confidence in myself. But I just did the sign chart. I don't know. Once again, my handwriting's a little.
Let's see. X minus 3. So that's, yeah, you're doing fine. Yeah, you're doing fine.
On both?
Yep, so far so good. So now what you need to do is look at what's below. Oh. I'm just sort of catching up to you there.
Oh, okay, gotcha. Hey.
All right, let's see. So that would be I think I'm not seeing the bottom row of numbers is going to be, this is going to be the issue. Down below, this is where you want to think about, so if this is, if in this interval you have a negative here and a negative here, a negative times a negative gives me a what?
Positive.
So you want some plus signs here. And then what happens if you have a 0 times a negative?
It'd be 0.
And what if you have a positive times a negative?
Negative.
Negative. And what if you have a positive times a 0?
0.
And what if you have a positive times a positive?
Positive.
Okay, does that make sense so far?
Yeah.
See,
Okay.
you really want to do that bottom row because that's actually, this is where you're going to get your correct answer. Now, it looks a whole lot like the other one, but we have a difference in the inequality. What you do is you look back. The idea was we looked at the two factors separately so that eventually we could look at the factors together. Notice that in this example, the product together was greater than 0. In this one, the product together is less than or equal to 0. So that's going to be what will tell you what sign to choose. Do you want positives or do you want negatives? This time you wanted positives. Greater than 0 means positive. This time, though, it's less than 0.
You want negative.
So you want negatives. And because it says less than or equal to 0, you want to include anything that would give you a 0 and anything that would give you a negative. So what do you think, with that in mind, what do you think the solution might be?
Was there part of it that I did was correct or no?
Everything was fine. I think you did the top part. I didn't see that you had this bottom row.
Yeah, I didn't. Yeah, I didn't do that part.
Yeah, that's really important because that's where you're taking the two factors that you had looked at separately and you're putting them together. And it's that line where you've put everything back together that you decide upon whether you want positives or negatives.
Negative infinity, comma, -5, correct?
Well, let me back up before you do that. Do you want the product to be positive or do you want it to be negative?
Negative.
Negative. So we don't want that part.
Oh, I think I see what you're saying. So it'd be -5. Okay, -5, comma 3. Oh, okay, I see where this is going. So would that be your answer? Or no,
I've got to have some parentheses or brackets.
Gotcha.
Do I want parentheses or do I want brackets?
Brackets.
Yes, because it's less than or equal to.
Equal to.
Those places that have the equal to. So this time the solution was 2 parts because you wanted positive. Here you wanted negative, so you only ended up with 1 part.
Gotcha. And then I'm assuming the next part would be well, the U.
You don't need a union this time.
Oh.
The reason you needed a union is there were 2 intervals that worked for this question, but there's only 1 interval that works for this question.
Oh, okay, because you're just looking for well,
you're looking for the negatives, and there's only 1 place where you have.
Oh, okay, I see what's going on. Okay, gotcha. So that's why that part is very important. That's why you were mentioning that.
Yes, that's why you really want to do that.
Okay, you only want the parts where it's. Oh, okay, that makes complete sense. Wow. Alrighty, well, yeah, that. Wow. Okay, now I see. Because I kind of skipped over that part, and I was like, oh, well, maybe I could still solve it without that because I didn't really understand it, but now I really do. So you're just basically, you're working from the very top one to the bottom, and that's how you get the last one.
Right. Yeah. These inequalities where you either have a quadratic expression or a fraction are way too complicated to try to deal with as they are. So basically what the sign chart does is it takes it apart into individual factors that are easy to think about. And once you've thought about them separately, then you can put them back together. And that's going to be simply a matter of, in every case, of what's a negative times a negative, what's a positive times a negative, what's a 0 times a negative. Or if there's fractions, then it's negative divided by negative, or positive divided by negative, or 0 divided by negative, or whatever it might be.
Yeah. So anything that is greater than 0. So then in this case, how come you wouldn't use the positives on the side since those are greater than 0? Well, yeah, yeah, yeah.
That's because the inequality that the ultimately the inequality I was interested in was blah 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 less than 0, less than or equal to 0. So if it's less than or equal to 0, I want to either have the product turn out to be negative or 0, not positive. So I don't want to use anywhere that's got plus signs. I only want to use the parts that have negative signs.
Okay.
Greater than 0 positive, so I like all the plus signs. Less than 0 negative, so I want all the negative signs.
0 negative. Oh, okay. Oh, okay. Sorry. Yeah, it's a stupid question. Okay, I get it.
It's okay. It's okay. And this pattern can be different. So you might have some big problem you're working on, and when you get down to the bottom, you might have a 0 0. Maybe it would be negative positive negative. So this one was positive negative positive, but maybe it'll be negative positive negative. It could be almost any pattern imaginable. And in each case, then you decide, okay, if I want the negatives, then there would be 2 pieces, and I would take both of those.
Gotcha. Okay. Awesome. So yeah, okay, yeah, because you want the negative anything less than 0, and then the other one you want anything greater than 0. So that,
Yeah.
okay.
So maybe this is a 3 and this is a 6. If you wanted it to be less than 0, you would go negative infinity to 3, because there's 2 pieces that are negative, and then 6 to infinity. And the only way to know what kind of pattern you're going to get is to go through this whole long process and just see what happens.
Yeah, for sure. Right. I definitely would love to do these again by myself.
Yeah. So I am probably going to need to go here pretty soon, but
Oh
definitely
no, yeah. No, you've definitely
explore
given enough
these.
time for sure.
Yeah, but as soon as this recording is done, I will email it to you. Yesterday was pretty fast, or whenever we did this last. It was done in about an hour or two. So, try some more, but soon you'll have the video and you can watch this whole thing again.
Gotcha.
So before we go, I do want to talk about a couple of things that you do need to look at. So I'm going to switch the camera back to me. Yeah, so there's a couple things that you're going to need to do before you can take the test. I don't think you've done these yet. So the first thing you need to do when you go into your assignments, that you're going to see something called a tech check. And what that is there for is just to make sure that the mechanics of taking the test are going to work for you. And hopefully you've seen this in the emails that have been coming. I'm going to share the screen and just kind of show you where this is. All right, let me open up a window here. Okay, and I realize I'm going to have to, let's see if it still shows up here. I'm going to have to change the deadline on this too, I think. But when you go through your list of assignments, you'll see something called Tech Check for Test 1. You're going to want to do that. Now, this is not for a grade. It is just simply to make you comfortable with the idea of logging into a MyMathLab test and seeing that all the help screens are turned off. And most importantly, making sure that you know how to upload your scratch paper when you're done. You do have to upload your scratch paper within half an hour of finishing your work.
So that's just basically work we do on paper, right? And we just send it.
Yeah. So when you're working through the test, just do your work neatly on paper too, because I want to see that. Okay. Now, the password for the tech check is the word joking. Joking with a capital J. Joking.
Hmm?
And that will make sense once you open the test. You'll see why I chose that. Okay.
Yes.
Now, what you'll need to do is you'll need to review how to upload your scratch paper into document sharing. And you may want to take a few minutes to go back to your over here under Welcome to My Class and watch the video on tests again, because this video talks about basically the mechanic of taking tests, but it also talks about how to use the document sharing feature, how to make a PDF out of your paper, and how to upload the paper to your into document sharing. Document sharing is down here. And what that does is it gives you a place to put scratch work from all your various tests as the semester goes along, so I can see it. So you want to do the tech check to make sure that you can do all of those things. And then the test itself has its own password, which is not joking. And I am sending that through Remind, our text messaging system. And I just checked, you haven't signed up for Remind yet. You're going to have to, because that's the way I'm going to get you the password for the test. So Remind text messaging, there's instructions on how to do that right here. And it talks about how to set up your Remind account so that I can text you. And as soon as you've done that, I will get a note in my text messages that you have set it up, and I can text you back and tell you what the password is.
Okay.
And this is actually really important to do because I'm sending text messages a couple times a week, and you're not getting those. The text messages are reminding you of important deadlines. When the hurricane was going on, I was sending updates about the school being open and closed. So you really want to make sure you're getting those. It's going to help you stay on track easier by having those text messages. So, but for most immediately, you need it so that you'll have the password for the test. So do the tech prep. Watch the testing video again so you're sure you know how to upload your scratch paper.
Mhm.
And then sign up for text messaging through Remind so I can send you the password, and then you'll be ready to go on the test.
Yeah. Oh. Hold on, give me 1 second.
Okay, sure.
Sorry about that.
Oh, okay, no problem.
Mhm.
So is all that okay? Does that give you some good marching orders to follow?
Yeah, I just saw, yeah, I know I'm doing it last second, but yeah, I mean, I've just been so worried about the well, I guess you could say worried about the test that I just kind of goes out of mind. But
Yeah,
but I definitely will. Obviously, this is something I need to do in order to take the test. So
yeah, it's the mechanics because
yeah,
I am looking at that scratch work, and so far there have been some students that they got their grade back initially and they thought, oh my goodness, I did really bad. But when I looked at the scratch work, they maybe just made one little sign error or something, and I can go back and adjust the grading and give partial credit. But I can only do that if I have your scratch paper.
gotcha. Okay. So you give points from seeing our work, well, like if it's somewhat correct or
I do. Yeah. Yeah.
okay.
So that can make a difference. Sometimes it's not making much of a difference, but some people it's made like for one person, it made almost 30 points difference because there were some questions that were 10-point questions graded right or wrong. And it turned out they made one little tiny mistake.
Mm.
And once I went back and fixed that, then their grade went way up.
Okay. Awesome. Well, yeah, Professor, thank you so much for your time once again. I know that you definitely sticked around for a while, so I
You are,
appreciate that so much.
yeah, you are very, very welcome. Very welcome. I hope all this helps. And we covered a lot of ground. And I, I think, I think we've probably covered pretty much everything you're going to need to know at one point or another. I'll just send you this recording as soon as it's done, and you can look at it again. And I hope you do really, really well on the test.
Yeah, so do I. Yeah, I mean, studying a little bit more later on. Well, I don't know. I'm very tired, so hopefully, you stick around about an hour or two, and then definitely waking up tomorrow early in the
Yeah.
morning, and I just want to get it done by in the morning tomorrow. So we'll see
Okay.
how it goes. Yeah. No, well, thank you for your help. I mean, it's definitely, man, I was hopeless in the beginning, but it's definitely helped a lot for sure. So
Good. Good.
yeah. Yeah,
We'll
so
do great, and we'll see how it goes. And I'll definitely send you some feedback once I've had a chance to look at it. So so good luck.
alrighty. Thank you, Professor. You
Okay.
take care.
All right. Okay. You too.
All
Have a
right.
good evening.
You
Take
too.
care.
Thank you.
Bye bye.